Everyone. Today we are discussing chemistry theory paper, Feb March 2026. Starting with the first question is give the symbol of the element that is the catalyst in the Haber's process. So we know that the catalyst is iron, finely divided iron is used. Second, it is used to galvanize iron objects. So zinc is used in galvanization. Next, we have has a blue anhydrous chloride used to detect the presence of water. So we know it's cobalt chloride test. So it is cobalt. Now, next is the catalyst used in the reaction of alkenes with hydrogen. So we know it's nickel. Next, we have the question forms a green precipitate with aqueous sodium hydroxide, which is added to an aqueous solution of its ions, which dissolves in aqueous sodium hydroxide. So it could be iron or chromium, but iron, in case of iron, the precipitate will not dissolve in aqueous sodium hydroxide. So the correct answer is chromium. Next question forms an ion that has 24 electrons and a 3 plus charge. So ion that has 24 electron and 3 plus charge, that means the atom should have how many electrons? 24 plus 3, which is 27 electrons. So for an atom, the number of electrons and number of protons will be same. So number of protons will also be 27. That means the atomic number should be 27, and the atomic number 27 is cobalt. So the correct answer is cobalt. Then it forms brass when mixed with copper. So we know the alloy brass is a mixture of copper and zinc. Let's move to the next question. Now, name the main ore of aluminium. So we know the main ore of aluminium is oxide. Next, name the process in which aluminium oxide is broken down into its elements. So the name is electrolysis, and the process basically it's Hall-Herold's process, which is the electrolytic process of extracting aluminium. Next, name the substance which is added to aluminum oxide to reduce the operating temperature of this process. So we know it's cryolite. Cryolite is the substance that is added to the aluminum oxide, and it reduces the operating temperature. Now, B part of the question says state the type of oxide that reacts with both acids and bases. Then that is amphoteric oxide. Amphoteric oxides. Next, we have state the name and give the formula of the salt formed when aluminum oxide reacts with dilute hydrochloric acid. So aluminum oxide plus hydrochloric acid forms aluminum chloride. So we'll write down the name aluminum chloride, which is the salt, and water is also formed. And the formula is AlCl3. Next we have is the equation, completing the equation. So Al2O3 plus NaOH gives NaAlO2 and H2O. Now to balance this, we have NaAlO2 and Al2. So we have to put 2 so that aluminum gets balanced. Now sodium is 2, so we have to put 2. Now hydrogen is 2. Hydrogen is 2. Now it's balanced. Next we have the formula of the anion in NaAlO2. So Na is plus, so that means Al should be minus. Next we have indium has an atomic number of 49, and state the number of occupied electron shells in an atom of indium. So for that, to find the number of occupied electron shells, we have to find the period number. So from the period number, we can easily find out the number of electron shells. So this is the periodic table. So where is indium? Indium is here. Now you can count the period number. This is 1, 2, 3, 4, and this is 5. So number of electron shells is 5. Number of occupied electron shells in an atom of indium is 5. Now, the sample of indium contains 2 isotopes. We have to put the number of protons and number of neutrons. Number of protons will be same, which is 49. Because in isotopes, proton number remains the same, and neutron number changes. So the neutron number will be the mass number or the nucleon number minus the proton number. So 113 minus 49 will be 64, and 115 minus 49 is 66. Next, show the relative abundance of the two isotopes of the sample of indium. Now, relative abundance is given, not the percentage abundance. So, how to calculate this? To find the relative atomic mass, uh, this will be the mass or the nuclear number of this isotope into the fraction, which is 1 by 19, plus 115 into the fraction, which is 19 by 20. My bad, this should be 20. So this is 113 by 20 plus 15 into 19 by 20. And this gives you about 114.9. So answer is 114.9. This is the relative atomic mass. Next, we have question number 3. The salt sodium chloride can be repaired, and the reaction is given with method 1 when sodium metal is placed into a gas jar of chlorine gas. Whereas in method 2, dilute hydrochloric acid is added to a known volume of aqueous sodium hydroxide and in the presence of an indicator. Now, the first question says, state the color of the flame sodium metal burns with before it is placed into the chlorine gas. So, flame test, basically, flame test of sodium metal is yellow flame. Sodium burns with a yellow flame. Next, state the color of the chlorine gas before. So, color of chlorine gas. So, it's green, or you can say pale green color. Pale green color. Next, we have calculate the mass of the sodium chloride formed when excess burning sodium metal is placed into 960 centimeter cube of chlorine gas at room temperature and pressure in method 1. So the reaction in method 1 is 2Na plus Cl2 gives 2NaCl. Now we can write down that 2 moles of sodium reacts with 1 mole of chlorine to give 2 moles of sodium chloride. We have 960 centimeter cube of chlorine gas, and this is at room temperature and pressure. So we have to find the number of moles of chlorine gas, which is 960 divided by 24 dm cube. That means 24 into 1000. Now this gives as 0.04. So number of moles of chlorine which is present is 0.04. Why we are not taking for sodium? Because they have already said this is in excess. So we will start with the limiting reactant. This is 0.04. So since the mole ratio is 1:2, this will form 0.08 moles of NaCl. Now we have to find the mass of the sodium chloride. So mass is equal to Mr into moles. Mr for sodium chloride is 58.5 into moles is 0.08. This gives as 4.68 grams. Next question, write the ionic equation which represents the neutralization reaction. So we know neutralization reaction is H plus plus OH minus aqueous gives H2O liquid. This is the ionic equation for neutralization. Name a suitable indicator to use in method 2. So for this method 2, the indicator we can use is thymethylene, or you can also use methyl orange. Name the experimental technique used in method 2. So method 2, the experimental technique is titration. Next, C part of the question. You have to complete the dot and cross diagram of the ions in sodium chloride. Now this is sodium, and we know that one of the electron is lost. So we have one more shell left to draw, which is 1, 2, 3, 4, 5, 6, 7, 8, and plus charge because one of the electron is lost, and that's why the outermost shell is removed. But in chlorine, one electron is added, so we have 3 shells in chlorine. So we will add one more shell here. 1, 2, 3, 4, 5, 6, and 7, and 1 from sodium. Next, molten and aqueous sodium chloride are separately electrolyzed using inert electrodes. Name a suitable inert non-metal electrode and a suitable inert metal electrode. So we know a non-metal electrode which is graphite electrode, and a metal electrode is platinum. Next we have is to complete the table 3.1 to show the name of the product formed at the cathode. So you have to find the product at cathode. When you have molten sodium chloride, so cathode will be sodium only because there is no other ion present. In dilute aqueous solution, so for dilute, we have to check the reactivity series, and hydrogen comes below sodium in the reactivity series. So that's why hydrogen is formed at the cathode. In concentrated, we just have to check the reactivity series. Again, hydrogen will be formed at the cathode. So that's it for today. This is for part one. Stay tuned for part two. Thank you.